Okay, let's take a look at parts Y and Z. The first thing I do need to address here is there's a typo on Y. This 1 up here should technically be a pi. So let me just go ahead and white out the 1 and turn that into a pi, which is good because this becomes very, very difficult if there's no pi up there. All right, so real quick, the graphs of d of x and h of x are shown above. And let's see, h of x for the interval from 1 to 3, k equals 2. So because k equals 2, the h of x that we are working with is going to be 2x squared minus 8x plus 6. We can get that from the top of the page. So to do area between two curves, you're just going to take the integral of the top function, which is d of x, minus the bottom function, which is h of x. So it looks like the integral from 1 to 3 of the upper function, which is d of x, minus h of x. I don't know why this is so slow. Hopefully it'll catch up. All right, equals the integral from 1 to 3 of, and usually what I'll do here is I'll open it up with a bracket. This way I'm going to go the upper function here minus the lower function here, close it, and then put the dx at the end. All right, so I get the top function, which is negative sine of pi over 2x plus pi over 2. And notice again what I did here is I pulled the x off the top. Okay, so it's just easier, I don't know, when I look at it to see it as a coefficient if the number is out in front like that. Minus, and then we have, and I'll tell you what we're going to do. I'm going to go ahead and distribute that minus through h. That becomes minus 2x squared. Then that becomes a plus 8x, and that becomes a minus 6 dx. All right. Let's see here. Now, we do have a slight issue here in that we have a composition. I have an inside and an outside. And the derivative of this inside is actually going to be pi over 2. So we do have to do some form of substitution. So I'm going to go ahead and do that for this. Now, the thing to keep in mind is I only have to do substitution on this first piece. So the bounds are going to change. I'm going to have u in here in just a second. But everything else after that will remain x, and the bounds will remain 1 and 3. So I'll show you what it means in just a second. So u is going to be pi over 2x plus pi over 2. So du is going to be just pi over 2 dx. Now, notice we don't have an extra pi over 2 on the outside, so we are going to have to put one in and counter it with a 2 over pi outside of that. I'll show you that in a second. My bounds are upper bound is 3, lower bound is 1. So x is, well, let's see here, if x is 3, my apologies, then u is, well, if x is 3, pi over 2 times 3 is 3 pi over 2, plus 1 more pi over 2 gives us 4 pi over 2, which simplifies to 2 pi. And if x is 1, that just makes it pi over 2 plus pi over 2 is 2 pi over 2, which is pi. So here we go. Again, I am going to have negative sine of pi over 2x plus pi over 2, and I need a times pi over 2 dx here. But in order to put that pi over 2 in there, I have to put a 2 over pi on the outside. My bounds are no longer 1 and 3. They are pi to 2 pi. Actually, bear with me. They are still 1 and 3 as long as it's x in here. I haven't substituted the u in there, so it's going to stay that way. Minus the integral from 1 to 3 of 2x squared plus the integral from 1 to 3 of 8x dx minus the integral from 1 to 3 of 6 dx. And there should be a dx here too. The thing you've got to be careful, because I did minus and I distributed the negative up here, I can't put minus the integral of the entire thing. Otherwise, I'm pulling that negative back out. So if you do that, then you'd have to change both the 8x and the minus 6. Okay. So now let's go ahead and put the u in. So I get the integral from 2 to pi, 2 over pi times the integral from pi to 2 pi, negative sine u du. I'm just going to leave these here for right now, and then we'll integrate everything together. All right, so I have a 2 over pi. The integral of negative sine, well, remember the derivative of cosine is negative sine. So the antiderivative of negative sine would just be cosine of u, evaluated from pi to 2 pi, minus, this is going to be 2x cubed, evaluated from 1 to 3, plus, this is going to be 8x squared over 2 from 1 to 3, and 6x from 1 to 3. So I get 2 over pi. Now the fundamental theorem, so cosine of 2 pi minus the cosine of pi minus, now let's do the same thing, so 2 times 3 cubed minus 2 times 1 cubed plus 8 times 3 squared over 2 minus 8 times 1 squared over 2 minus 6 times 3 minus 6 times 1. Now, I am going to leave it here. As soon as you get to the point where there's no variables or anything, this is just a calculation, you are done. Okay, I'm going to go ahead and put the answer here. It wouldn't be bad for you to try to work that out to make sure that you can get that. But that's what that would boil down to. Right. I'm going to do Z because this is pretty quick because all we're doing is we're setting up, but we're not evaluating that there. So what we want to do is set up but do not evaluate an expression involving one or more integrals that gives the volume when the region bounded by the graphs above is revolved around the line y equals -5. So what we're saying is we're taking this region here and y equals -5. Now, I'll talk about this in just a second, but let's just assume it's down here for a second. We are revolving this entire thing around that line y equals -5. All right, now, real quick, we don't know, because this is a different part of the question, so that whole k equals 2 that we did up here was only for y. For part Z, I don't know what k is, so h could be below, could be above, it doesn't really matter, but we do know d is above the line, or the line is below the function, all right? So we're going to go ahead and the volume would be pi times the integral from 1 to 3 of, and the way this always works is it's something squared minus something squared. It's always the function minus the line or the line minus the function. Okay, that's what's going to go here. Function minus the line minus the function, depending on which one. Now, if the line is below the function or the function is above the line, it's just like we did before. It's always the upper minus the lower. So since in this case here, the function is on top, we want d of x minus the line. And then the same thing here, h of x minus the line. That's all that you'd have to do here. You'd have to throw on the dx at the end, and that's done. And that's a journey through calculus from A to Z. So I hope that was a beneficial review. Hope that kind of refreshed you in a couple areas. And if you guys have any questions, by all means, reach out and ask.